In the first law of thermodynamics, there are commonly two types of problems. One is steady flow and the other is unsteady flow. So flow through turbines, nozzles and compressors, pumps comes under the steady flow, whereas charging of a pressure vessel through a compressor comes under the unsteady flow. So to understand the unsteady flow, it is better to take an example, and through that example just go through the fundamental equations of conservation of mass and conservation of energy and derive the final result. So in this there is a problem where a pressure cylinder of volume V, so this is a pressure cylinder of volume V, contains air at a pressure of P naught and temperature T naught. So initial pressure and temperature P naught and T naught of this pressure vessel has been given, and the volume of this vessel is V. So now this vessel is being charged from a pipeline which is being maintained at a pressure of P1 and temperature T1. So when this valve is opened, then this compressed air will start flowing into this tank, and since P1 is greater than P naught, so this flow will continuous until P naught reaches to P1. So let us first take the conservation of mass. Now to determine the conservation of mass equation, first we need to calculate the initial and final mass. So initial and final mass, when the charging of this tank was not started, if we take the mass as m1, then P naught V is equals to m1 r T naught corresponding to initial position. Therefore m1 is equals to P naught V upon r T naught. This is equation number 1. Similarly, at final point, let us suppose the m2 is the final mass, then at state 2 pressure will be equal to the compressed air line, therefore pressure will be P1, volume will remain constant P1V is equals to m2 into RT2. T2 we have to determine the final temperature. So we have taken the final temperature as T2, therefore m2 will become P1V upon RT2. Now m in minus m out is equals to m2 minus m1 within a control volume for a time period, suppose we take as delta t. Since there is no outflow of mass, therefore m out will be 0. Therefore whatever mass entered is equals to the final mass in the container minus initial mass. So it will come as P1V upon RT2 minus P naught V upon RT naught. So this is equation number 2. Now we have taken this pressure vessel as insulated, so there is no heat loss from this vessel. Further, we also take assumption that potential energy and kinetic energy changes are negligible. So applying conservation of energy, so E dot in minus E dot out is equals to dE by dt for a control volume. For a definite period of time delta t, this will be E in minus E out is equals to E2 minus E1 control volume. Now we have taken assumption as potential and kinetic energy is equals to 0 changes and insulated vessel. Therefore there is no outgoing energy, therefore E in will be is equals to m in into H in, that is enthalpy of incoming air, and E2 will be m2 U2 minus m1 U1. Therefore m in into H in is Cp T in. So incoming air's temperature is T1, therefore writing it as T1 sorry. is equals to M2 U2 is C1 T2 minus M1 U1 is here CV into T naught. T naught is the temperature corresponding to the initial state. We have not to be confused with the initial and T naught. So initial though is a state 1, but it is to be represented by T naught and P naught as initial pressure and initial temperature. Therefore, M in we have calculated as P1V upon RT2 minus P0V upon RT0 into Cp T1 is equals to M2 we have calculated as P1V upon RT2 Cv T2 minus M1 is P0V upon RT0 into Cv T0. Now this equation can be simplified as V by R is common on the left hand side and right hand side. So V by R can be cancelled out. So V by R cancel from both left hand side and right hand side. This Cv can be brought to this side and this Cp by Cv can be written as gamma. Further, this T2 and T2 will cancel out and this T0 and T0 will cancel out. Therefore, writing this equation after simplification is P1 upon T2 minus P0 upon T0 into gamma T1 is equals to P1 minus P0. Therefore, P1 upon T2 times gamma T1 minus P0 upon T0 into gamma T1 is equals to P1 minus P0. We have to find out the T2, that is the final temperature in the pressure vessel. Therefore, simplifying the for T2, P1 gamma T1 upon T2 is equals to P1 minus P0 plus P0 T0 into gamma T1. Therefore, T2 can be written as P1 times gamma T1 divided by P1 minus P0 plus P0 upon T0 times gamma T1. Therefore, further simplifying T2 is equals to gamma T1 divided by 1 minus P0 upon P1 plus P0 upon P1 into gamma T1. Therefore, simplifying the final temperature in the pressure vessel after charging, this will come as gamma T1 divided by 1 minus 1 plus P0 by P1 gamma times T1 by T0 minus 1. So this is the final temperature in the pressure vessel once it reaches to the pressure equivalent maintained in the pressure line. So हमसे पूछा गया था final temperature in tank if charged to pressure of the line T is equals to gamma T1 times P0 by P1 into gamma times of T1 by T0 minus 1. So this was the final solution as well as the analysis for the unsteady flows.